All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up number 18 is on the screen. You don't need your Chromebook, so you get started right away, please. Today, we're moving on to a new part of polynomials, just to let you know, FYI, BTW. So stay focused. See how you do with that warm-up? Nope. Whoa. All right, number 1. What'd you get at the end, Rebecca? Okay, I missed the first part. Squared minus 1. All right, so notice today I did a little curveball. I switched 1 and 2. Yesterday, number 1 was subtraction. Today is what? Multiplication. So, what do we need to do here, everyone? Choose one of the 3 methods and multiply. So let me go over this one just to make sure we got it. Here it goes. So I'm going to start using distributive property with 3y. 3y times 2x squared y, that's 6x squared y squared. 3y times 1 is 3y. 3y times negative y, that's negative 3y squared. All right. Next, 4x squared times 2x squared y, that's positive 8x to the 4th, y to the 2nd. 4x squared y times 1 is 4x squared y. 4x squared y times negative y is negative 4x squared y squared. Woo! I like these. Let's go. Then we got negative 2 times 2. That's negative 4x squared y. Negative 2 times 1, that's negative 2. And negative 2 times negative y, that's positive 2y. Let's go. All right, so combine. Do we have, I'm going to start with the highest degree. What's my highest degree? Let me scan this. This is 4, 1, 2. This is 6. So I'm going to start here. Is there another x to the 4th y squared? No, so I'm going to write 8x to the 4th y squared. Next, I think the next one is this one right here. 6x squared y squared and minus 4. That is positive 2x squared y squared. So far so good, yes? Yes, Mr. Q. All right, good. Next, we got 4x squared y. Is this a minus right here? And minus that, that's a 0 pair? Is that correct? And then we got, next up is y squared. Is there another y squared? No, so it's negative 3y squared. And then from there, 3y plus 2y, that's 5y. And at the end, minus 2. Ooh, that was a long one. Okay. Hands, you got that by yourself? Oh, yeah. Right on cue. See what I did there? Right on cue. Let's go. All right. And I'll tell you a little story about that one. Rebecca, pass number 2 to someone. Share with your neighbor first what you get for number 2. All right. Pass that one, Rebecca. Oh, let's go. So number 1, I took out the negative and I moved it to the second one, so I need to distribute that negative 1 to each of the 3 terms over here. So that gives me positive 3x squared minus x plus 1. Check your work to make sure you got that. Yes? Yes, Mr. Q, we love these. All right. X squared plus 3x squared, that's 4x squared. Then we got 5x minus 1x, that's 4x. And 6 plus 1, that is 7. Hands, have you got that? All right, not bad. Number 3. Let's see. How about, who haven't we called on in a while? Brandon, Doherty. What'd you get for number 3? Less than what? -8. Hands, have you got that? Close. Tell your neighbor what to change. What's the only thing that changes? What was it? +8. Is that correct? All right. And last but not least, let's go to number 4. I'm going to go over that one more time. 30. What pairs of factors give us 30? 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then they repeat. About 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then they repeat. 18 is 1 times 18, 2 times 9, 3 times 6, and then they repeat. Yes? All right. So do they all have the smallest one, which is 1? Yes. How about 2? Yes. How about 3? Yes. How about 4? 5? 6? Yes. And that would be the greatest one. So GCF is 6. Hands, if you got that by yourself. All right. So far, so good. Copy the agenda, please. Warm up number 18. Today we're moving on to binomial theorem. Let's go. I love this one. And tonight's home play is going to be 8 problems only. Thank you, Mr. Q. You're welcome. I got you. 6KYWR. That's your code for today. Make sure you write that down. That's how you're going to get your home play. So, last night's home play were these. So go ahead and go to Canvas, turn that in right now. Tonight's home play are those. Only 8 of them. All right. After that, get a Cornell note. I'll give you some time to set up your Cornell note. You don't need a fair model. Yes. All right. I can multiply polynomials. So within the umbrella of multiplication, today we're going to continue. We already know what polynomials are. Shall we share the definition with your neighbor? Yes, tell your neighbor the definition of polynomials. By now they should know. All right, looks like Martin's got it. Martin, definition for polynomials. Yeah, monomials or some indifference of monomials. What's that? All right, so we got that, yes? All right, so then from there, really quick, I just want to have you pay attention to this. We're talking about patterns now. Today, I'm going to focus on patterns because it relates to what we're going to cover with a theorem. So, in life, in nature, there's patterns everywhere. Believe it or not, all of these are formed within fruits, vegetables. Here's a shell. That's why I have that shell over there. And they all have a pattern. All those patterns can be managed with numbers. That's why there's a lot of stuff that your cell phones, stores are getting into biometrics now. Why? Because of those patterns. Check this out. I'm pretty sure here's a pattern right here. Has numbers. Well, guess what? That applies as well to digits. So here, do you guys see here how it starts forming a little pattern? That's why they're able to put numbers to our digits, our face recognition and stuff like that. And it's coming. I'm just giving you a heads up. Well, there was a mathematician, a French mathematician. His name was Blaise Pascal. He was into patterns. And he found out a pattern, and he called that pattern Pascal's triangle. Now check this out. I made an animation for this, so look up to the screen so you can see it. I'm not going to talk. I'm just going to have you see it, how it fills in. So I hope you see that it starts with a 1, then 1, 1, and on the edges, it's all ones, but what goes in the middle? Here it goes. Here it goes again. And one more time. All right, share with your neighbor how that pattern works, please. How does that pattern work? All right, I think we got it. So check this out. I want you to write on your paper Pascal's triangle. Don't copy this one. I'm going to show you how to write it so like that we don't have to draw the little honeycombs. So Pascal triangle, this is how it starts. On the side or underneath that, start with a 1, then 1, 1, and then you start with a 1, you add those two, and then you get a 1 to end it. And again, you started with another 1, you add these two, 1 plus 2 is what? 3, 2 plus 1 is 3, and then you end it with a 1. Let's go to the next one. Next one. 1. What is 1 plus 3? 4. 3 plus 3? 6. 3 plus 1? 4. And then you end it with a 1. That's how you start forming your Pascal triangle. Let's go one more row. 1. And see if you can fill it in all the way, that row. All right, show your neighbor your row. Make sure they have the same thing. All right, let's see. You started with 1. Then we got 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then you ended with 1, and so on and so forth. All right, next to that, so here's the 1. Right above this line, I want you to write row. We're going to label these rows. When we start with the number 1, this is what we call row 0. That means this has to be row 1. This one has to be row 2, row 3, row 4, and row 5. So look at it. Now, one thing that I tell my students every year, the easy way to remember what row to use is by, let's say I ask you, I want you to write me row 4. Row 4. So that means you're going to start your little triangle and stop whenever you see what number? 4. I think that's the easiest way of knowing where to stop. Does that make sense? Yes, Mr. Q. All right, good. Any questions with the Pascal triangle? All right, so do me a favor, turn your paper over. All right, I want you to build me the Pascal triangle. Pascal triangle, but I want you to go to row 6 without looking at the previous one that you did. Turn your paper over, build it all the way to row 6. All right, here we go. You should have done 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. Hands if you got it to right there. And you stopped that there because you saw the number what? 6. All right? From 1 to 5, how comfortable are you with a Pascal triangle? Yeah. Well, Pascal found that the Pascal triangle is related to multiplying polynomials. He said, there's a pattern here that works when multiplying all kinds of polynomials, specifically any polynomial to a certain degree. So, before we get there, look up to the screen. I want to clarify the following. Look up. X to the 0 and 2 to the 0 is always 1. So what can we conclude? Any number to the 0 exponent is 1. X to the first and 2 to the first is itself. So this would be X, and this would be 2. So that means any number to the first power is the number itself. So if I say 23 to the first power, the answer is 23, Michael Jordan, because he's number 1. Let's go. All right? Questions, comments? All right. What is 1 million to the 0 power, Brandon Felix? It's 1, yes. Any number to the 0 exponent is 1. How about the number to the first power? It's that number. So 1 billion to the first power is what, Anthony E? 1 billion, yes. So it's the same number. Any questions with that? All right. So with that said, look up to the screen. Don't copy this. It says, find the product. So without writing anything down, tell your neighbor what that is. What is that? Everyone. 1. That is correct. That is 1. Therefore, x plus y to the first power. Tell your neighbor what that would be. X plus y. That is correct. That same thing. But then we start getting into funner stuff. This is one of the identities. I'm pretty sure you already memorized it, but I don't want to put you on the spot, so I'm going to call them my own. Q, answer that one. What is x plus y squared? Oh, it's x squared plus 2xy plus y squared. So what are you saying, Mr. Q? I need to memorize the identities? Yes, I only gave you 3. Make sure you memorize them. How did I get this, though? Well, this is to multiply it how many times? X plus y times x plus y. If I use distributive property, vertical multiplication, or area model, guess what that's going to give me? That. Everybody following? All right. But then it starts getting a little intricate. What if I said x plus y to the 7th power? You're like, what? What does that mean? It means x plus y times 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 x plus y, 2, 4, 6, and one more, times x plus y. And guess what? I start with these first, write it here, and then whatever I get, simplify it, and then I multiply times what? X plus y, and then whatever I get times x plus y. Is that a lot of work? Or we can have Brandon Felix start, and then he'll give us the answer at the end? No. I'm going to show you a shortcut today. And that shortcut depends on the Pascal triangle. All right, so let's do one together. Here we go. Copy this one. Example 3. Find the product using the binomial theorem. So, Pascal, like I said, related the Pascal triangle to finding the product of this binomial to any degree using its triangle. And that's what we call the binomial theorem. Now, there is a formula. I don't want to get into the formula because I don't want to get you confused. I want you to understand the process first. Does that make sense? Yes, Mr. Q. All right. Y'all ready? All right. Writing utensils down. Look up to the screen. You'll finish copying in a little bit. Here goes the process. Y'all ready? All right. So, first thing. If they give you a binomial to any power, to multiply that using the shortcut, which is the binomial theorem, you first need to build your Pascal triangle and stop at the row that they ask. What is that row? 5. Therefore, here it goes. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and I stop. Are we there so far? Copy that so far? And once again, I don't know if you notice, I use a lot of colors because it's easier to transfer a lot of the knowledge in our brain. Even though you might not notice it, it does go a little bit faster and smoother. So I'm going to use colors for this next part, but before that, I'm going to use this row 5, right? Row 5. Look what I'm going to do. Ready? Writing utensils down, look up to the screen or you're going to miss it. These are how many terms I'm going to end up with at the end after I multiply. How many terms? 1, 2, 3, 4, 5, 6, which means I do this. 1, empty space, plus 5, empty space, plus 10, empty space, plus 10, empty space, plus 5, empty space, plus 1. Did I use all of these numbers? Do each of them represent a term? Yes. I left the space because I'm going to show you what to do next. Copy that, please. So far up to right there, pretty straightforward. Is that correct? Yeah? All right. Here goes the next part. This is where it gives some people problems. But for you guys, I'm pretty sure it's going to be a piece of cake. So I'm going to start with blue. All right? So writing utensils down, look up to the screen. How many terms do I have in the binomial? 2. The first one stops there. The second one starts wherever you see a subtraction or an addition, and it stops there. Agreed? All right? I'm going to start with the first term. My first term is x. So I'm going to write that in parentheses on the first term here and to the 5th power. The next term, I'm going to write it again, but to the 4th power. The next one would be to the 3rd power. The next one, 2nd. The next one, 1st. And the next one, 0. Hold on. Before you copy, now I'm going to do the second term. Be careful with this one. Here it goes. -2. Instead of starting at 5, I start at 0. -2 to the 1st. -2 to the 2nd. -2 to the 3rd. -2 to the 4th. And at the end, -2 to the 5th. Copy that, please. All right? So, for this next part, I'm going to zoom in so you guys can see what I'm doing for each of those terms. And I'm here. So, writing utensils down, look up to the screen. Here it goes. Next step. I need to simplify each term. So here we go. I start with 1 times, what is x to the 5th power? X to the 5th. I got rid of that parentheses. Times, what is -2 to the 0 power? 1 plus 5 to the nothing, or 5 to the, there's an invisible 1, so I bring the 5 down, times, what is x to the 4th? X to the 4th. What is -2 to the 1st power? Yeah, times -2. Yes? All right. Next. Plus 10 to the 1st power is 10 times x to the 3rd is x to the 3rd times. What is -2 squared? That means -2 times -2. That is +4. Everybody see what we're doing? All right, start copying that, and we're going to finish the rest together. I'll wait for you to copy. All right, so I'm going to continue from there. Let's see, the next one. Plus. What is 10 to the invisible 1? 10 times x to the second power is x to the second times. What is negative 2 cubed? That means negative 2 times negative 2, that's 4, times negative 2, that's negative 8. Bless you. Bring down the plus sign. 5 to the invisible 1 is 5 times. What is x to the first power? X times. What is negative 2 times negative 2? That's 4. Times negative 2, that's negative 8. Times negative 2, that is positive 16. Plus 1, of course it's 1, times. What is x to the 0 power, everyone? Everyone, 1, that is correct, times negative 2 to the 5th power. So I don't know if you saw the pattern already. This is negative 2 to the 4th power, so you take 16 and multiply it times what? Negative 2, which is negative 32. How are we doing up to right there? Good? The last step, we just simplify it now, each term, now that we apply the exponent, and we're done. Here we go. I'm going to use just black. Here we go. What is 1 times 1? Times x to the 5th? X to the 5th. Plus. Here we go. What is 5 times negative 2? Negative 10. And bring down x to the 4th. I'm going to put that in parentheses because it's a negative. Plus, what is 10 times 4? 40. And bring down the x to the 3rd. Plus, what is 10 times negative 8? Negative 80. Bring down the x squared. Put that in parentheses because it's a negative. Plus, what is 5 times 16? Very good. Positive 80. Bring down the x. Plus, what is 1 times 1? 1 times negative 32. Negative 32. And we're done. So I took it slow, step by step, just to make sure you got it. Let me zoom out now, just so that we can see the process. Here we go. It said, find the product using the binomial theorem. They gave us x minus 2 to the 5th power. So what does the exponent tell us? Which row to build our Pascal triangle? What row did we stop in? 5. What do we do with those numbers? They became a term with a plus in between those numbers. From there, we started with term 1, started with the 5th power in parentheses, and each term that it went over, it lowered the degree all the way till we get to 0. The second term starts at 0 degree, and it builds up all the way till we get to the end to the 5th power. From there, we apply the exponents, and then from there, we multiply everything out to simplify, and we're done. From 1 to 5, how comfortable are you up to right there? 4 or 5, okay. Let's do another one. Copy this one. Example 3 cubed, x minus 3 to the 3rd power. X minus 3 to the 3rd power. I'll give you a head start, but before I do, tell your neighbor what row are you going to use for your Pascal triangle. What row? Everyone, what row? 3. That is correct. All right? I'll give you a head start. Go. So as you're working, I build my Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and I stop because I see a 3. All right? So how many terms is this going to have? 1, 2, 3, 4 terms. So I start with 1 space plus 3 space, plus 3, space, plus 1. Are we doing good? All right. What is my first term? My first term is x, so I write it in parentheses to the third power. Then x in parentheses to the second power. Next term, x to the first power. And x to the 0 on the last term. So far, so good? Yes, Mr. Q. Give us more. All right. Next term is negative 3, so I put that in parentheses, negative 3, but I start at 0 power. And then it builds up. Negative 3 to the first, negative 3 to the second, and it ends with negative 3 to the third. Hands if you got up to right there. Okay. Next step, we're going to apply the exponent. So we do 1 times. What is x to the third? Well, x to the third times. What is negative 3 to the 0 power? That's 1. Bring down the plus. What is 3 to the invisible 1 power? That's 3 times. X to the second is x to the second times. Negative 3 times 1 to the first power is negative 3. Plus. 3 to the first power is 3 times. X to the first power is x times. And what is negative 3 squared? That's negative 3 times negative 3, which is 9, okay, plus 1 to the first power is 1 times, x to the 0 power is 1 times, and what is negative 3 times negative 3 times negative 3? That's negative 27. I'll put that in parentheses. Hands if you got it to right there, okay. And last but not least, we multiply out all the terms. What is 1 times 1? 1 times x cubed, that's x cubed, plus what is 3 times negative 3? Negative 9, bring down the x squared, plus, what is 3 times 9? 27, bring down the x. What is 1 times 1? 1 times negative 27, negative 27. Let's go, Brandon. From 1 to 5, how comfortable are you with these? Okay, 4 5s, 4 5s, okay. Now, is that it? No, come on now. Let's go. Look at this next one. Oh, it's a positive. That's an easy one. Look at this one. What do you guys notice on the first term? As a 2. So instead of doing just x, in parentheses, you're going to put what? 2x and apply the exponent to 2x. So, let me get started with, you have 1 minute? Oh, we can stay for lunch. No, just kidding. No, as you're packing up, let me show you this one, okay? Here we go. What row am I going to build to? 3. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, so it's 1 space plus 3 space plus 3 space plus 1. Now check this out. This is what I'm talking about. 3x to the third power, 3x to the second power, 3x to the first power, and 3x to the 0. What is my second term? 1. So this would be 1 to the 0, 1 to the 1, 1 to the 2, and 1 to the 3. Here we go. I'm going to apply the exponents. Hold on, really quick. 1 times, what is 3 cubed? 27, and x to the third, x to the third. See what I did there? And then 1 to the 0 exponent is 1, and that's how you take the whole thing. Okay? You have the code for Nearpod. Make sure you do the practice tonight. See you guys tomorrow. And tomorrow's Friday. Let's go. Let's go. Friday's here. Bye.